You guys need to start with yesterday's notes. Please have yesterday's notes out and get to the page where problem numbers 7 through 13 are. All right, yesterday's notes, problem numbers 7 through 13. Please have those out right now. All right, 7 through 13, please have those out. I'm going to start with notes today instead of homework. I'll get to the homework in a couple minutes, but I first need to finish some problems from yesterday's notes to make sure we have a firm understanding of the two methods I listed yesterday. Again, you guys that are just joining, we're hitting up yesterday's notes today, right now. Yesterday's notes, please get those out first. Yesterday's notes. And go to problems 7 through 13 for me. Okay, a quick recap. Quick recap of yesterday to make sure we're all on the same page before we finish those notes. I gave you two methods of proving triangles congruent. Two. The first one was SSS, side, side, side. You have to have all three pairs of sides congruent, nothing else. You do not need to know anything about the angles, just side, side, side. Pretty easy to understand that one. The second one was a little bit more challenging, SAS, side, angle, side. If you're going to use side, angle, side, the angle needs to be in between the two sides. So if you look at my diagram, my yellow arcs there are in between the two sides, which they need to be to use side, angle, side. All right. When a diagram is marked up for you, you are not allowed to put your own markings on. I'm sorry, you're not. Here's the two things, just so we're all clear. What are you allowed to mark on your diagram? You can mark a reflexive side, a side that's shared with each other right on top, all right? A side that's shared. Or you can mark vertical angles if there are any in the diagram. Those are the only markings that you can put on yourself. If there's no other markings, don't put them on, all right? Unless it's reflexive or vertical, all right? Okay, so let's finish yesterday's notes up. Here's diagram number 7. I marked some stuff for you. I got two sides congruent and two angles congruent. I need to know side, 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 angle, side, not possible for those two triangles. Let's get better at this. First thing, as you look at the diagram, could you put any of your own markings on? Could you put a reflexive side on there, or could you put vertical angles on there? Do you have any of that so you can make your own marking right now? Can you make your own marking? Yes? No? Let's figure it out. Shoom, here we go. Sanjay, can you put your own markings on?
Yes.
Where?
On line MK.
MK. And you guys saw me do this yesterday. Anytime I have a shared side or reflexive side, I just put an X on it. Instead of a hash mark, you can put whatever you want on there. All right, now that's the only thing you're really allowed to do. So now you tell me, do you have side, 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 or do you have side, angle, side? Or you don't have either, so it's not possible. Which one do you have working here now? Going up 1, 15, provide. What do I have working here?
Side, angle, side.
Yes, you do. Side, angle, side. Because the given angles that were congruent, all right, they are in between the two sides. Hopefully you guys see that, why that's side, angle, side. All right, next diagram. Let's keep rolling. Number 8, I give you two pairs of congruent sides. First thing I'm always going to ask you, can you put on your own markings anywhere? Can you mark anything that you know is congruent? Shoom, here we go. Tyler, can you mark anything?
Yes, you can mark PR as a shared side.
There you go. I got a reflexive side, PR. I can mark that. All right, now what do I have? Side, 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 angle, side, or nothing. Boom, going back. Liam, what do I have here?
What was the question again?
Did I interrupt something? I have number 8. I've marked a reflexive side. I am looking for side, side angle side, or not possible to prove those triangles congruent.
That's side.
That is side, the most basic one we have. Pretty easy. Number 9. Can you guys mark anything on number 9? Anything you know is congruent? Sides or angles that you can mark confidently? Whew, here we go. Back. Sean. Anything you can mark congruent, Sean, other than what I've already marked?
Angle SUV and angle VUW.
Yep. SUT and VUW. You can mark the vertical angles. That's okay. But any other angles, you leave alone. You can only mark verticals congruent. All right. Side angle side, or not possible here. Woo, here we go. Sanjay, what do you got? What method or not possible?
Not possible.
Darn right it's not. If some of you are wondering, well, why isn't it side angle side? Because the angle's not in between. Angle, in between for side angle side. Questions there? That's a good 3 examples of all different types there. Side angle side, and not possible. All right, last thing I just got to be confident on before we move on to the homework is making sure you guys know what I mean by in between. So please, for numbers 10 through 13, draw yourself triangle ABC. Draw triangle ABC. All right, let's see if we can answer these questions. Can somebody give me the angle in between sides BC and side AC? What's the angle in between those two sides? Okay, let's go up top. David, what's the angle in between?
Angle ACB.
Yep, I'll just call it angle C, but you're right, ACB. Yep. All right, let's keep trucking. Give me the sides that include angle B. Now, when I say the word include, basically, angle B is in between what two sides? That's what includes means. Angle B is included between what two sides? Quinn?
Angle A.
Oh, no angles here. Angle B, what sides are included?
Side AB and side CB.
There you go. Good recovery, good. Next up, what angles include AB? So what angle surround AB? AB is in between what angles? Boom, let's go. Here we go. David, again, give me the 2 angles that AB is in between.
Angle A and angle B.
All righty. I'm feeling more confident in you guys. And then finally, somebody give me the side in between A and C. Quinn, going back to you. What's the side in between A and C?
Side AC.
Done. All right, all good? Everyone good? All right, I feel pretty confident you guys are picking up on what in between means now, hopefully. Questions at all there? I had something here before I get to the homework. Everyone's all good? All right, homework. Let's check out how we did on the homework. As usual, we will go over the proofs together. So let me go over the non-proof ones. On number 9, hopefully you've been looking at the answer key, hopefully. Number 9, you could not prove those 2 triangles congruent because a length from one triangle never matched up with the length from the others. All right, and hopefully you're going to hand in a lot of distance formulas for me. And I know I am not keeping this up so you can copy it down because you were too lazy to do the distance formula. Okay? In triangle MNO, 2 sides came out to be radical 10. And the other side came out to be 2 radical 5. So it was isosceles. I guess you could tell me that. And then in triangle QRS, one side came out to be 6, a second side 5 radical 2, and a third side radical 2. So these 2 triangles were not congruent because none of the sides had equal lengths.
For
For number 9, do we have to write down all the sides for both triangles? Because we could have just proved it with all the sides from one triangle and one side from the other.
That's fine, Eric. Yep, that's good for me.
Could you also like just do 2 of them, but like make them so that they're corresponding? So you could do MN and QR, and then see if they're congruent. Because if they aren't, then there's no way it could be a congruent triangle. Right?
As long as Christo, as long as you are given the congruent statement like you are here. All right. If I didn't give you the congruent statement, you couldn't assume this side matches up with this side. Okay. Good deal.
Thanks.
So yes, in this problem, yes, you could do that because I gave you the congruent statement, so you knew what had to match up. So good call. Yep, that's fine. Any other questions here before I move on? Anybody have any issues with 16 through 19? You didn't know why it was not possible side, 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 or side angle side. This is the first 6 questions of your quiz on Friday, by the way, as I mark 2 triangles and I ask, what's the reason they're congruent? If not, write not possible. So that's the first 6 questions on your quiz on Friday. There's something like this. But also remember, you're going to have 2 more reasons I'm going to give you today. Any issues 16 through 19 going? All right, proofs, number 6. Number 6 should have been a 3-step proof. Very basic, you will not get anything as easy as this on the quiz. Number 6. What should have been your step 2? What should have been step 2 here? Because you're not going to get anything easier here. All right. AC bisects BD. What do you got for me? Boom. Here we go. Oh, here we go. Zane, what's your step 2 for this proof?
BC is equal to CD.
What reason?
Definition of bisector.
Got it. There you go, guys. Definition of bisector should have been your step 2. Step 3, you tell me the triangles are congruent by what method? Boom, here we go. Provide. What method are those triangles congruent?
Side, side, side.
All right, that's it. 3-stepper. Very basic. Okay? Probably not going to give you anything like that again. Everyone all right setting up that proof? All right, 10, we got some work with. 12, excuse me. Number 12, we got a little, it shouldn't have been that bad, but this was a tricky, your textbook is tricky. Here's why it's tricky, everybody. Look at the givens. BD is perpendicular to AC. And what did the textbook do? It threw a right angle in there for you. But the fact that that angle is a right angle is not given. You have to put it in your proof. Just because the textbook marked a nice little box there doesn't mean that's given to you. You need to write that angle ADB and angle BDC are right angles. But Mr. Carlino, it was in the diagram. I don't grade your diagram. I grade statements and reasons. So it's got to go in there. Perpendicular lines form right angles. All right, and then you could tell me they're congruent. And again, this did not have to be steps 2 and 3. It could have came later on in your proof. ADB congruent to BDC. I'm all fired up now. All right angles congruent. All right. Oh, that wasn't even the trickiest part. Here was the trickiest part. Look at the other given they gave you. BD bisects AC. So your book's like, you know what? I'll throw you a solid. I'll even mark AD congruent to DC, which is what you get from that. All right, because AC is being bisected, AD is congruent to DC. That's not a given. You have to put that in your proof. You have to tell me in your proof that AD is congruent to DC. I don't care that they marked it on the diagram. It's got to go in your proof. All right, that wasn't given that those two sides were equal. It was not given. And this is definition of a bisector. So watch out for that in your textbook. I won't do that to you on a quiz or test, but your textbook does it all the time. It'll mark your diagram nice and beautiful, but it actually wasn't given to you. So it's got to go in your proof. All right, I need to catch my breath there. Now, with all that being said, you're still missing something. You have a pair of angles and you have a pair of sides. You need one more pair of congruent parts to finish this proof off. Where was the other pair of congruent parts in this diagram? What am I missing? What am I missing? Tim, what am I missing? What's the other pair of congruent parts?
BD?
It's shared, isn't it?
Yeah.
So we can always count it as a side. Why is BD congruent to BD, Tim? By what postulate?
Reflexive.
There you go. There was your other missing piece, guys. Reflexive. And then now you just tell me the two triangles are congruent by what method? Here we go. Tim, again, redemption. What method are these two triangles congruent now?
SAS.
There you go. Side, angle, side. Good. Everyone good? A little longer proof, 6 steps. Probably the longest one we've had in a while.
So reflective applies to lines and angles as well?
Yes, even though we have not done one until today, we have not done one that we've had a reflexive angle. But yes, Tyler, if you have a shared side, and it's got to be a full side, a shared full side or a shared full angle, reflexive applies to both. Yes. Good question. All right, so there's 12, and then we had one more here with number 24. 100% my mistake. I am not making excuses. It was a mistake that should have never happened. On your homework answer key, I said number 24 should be 3 steps. It should be 4. That is 100% my fault. No excuse on my end. I should be better than that. All right, so why was it 4 steps? Here's the 4 steps. Given. Step 2, you had XZ reflexive to itself. And I'm going to ask you for the in-between step here. These were congruent, and in the givens, they also told you, oh, welcome back, parallel lines. Welcome back. I need somebody right now. Where are those special angles formed by those 2 parallel lines right there? XY and WZ. Name the 2 angles that are formed by those parallel lines that we referred to as special angles last unit. Dun, dun, dun. There we go. Sanjay, on fire today. Do you have those 2 special angles I needed?
Like the name of them?
Name the angles on the diagram, correct.
Angle W or YXZ and WZX.
There you go. I'll mark them on the diagram as well, referring to these 2 right here. All right, if we don't remember what those are called, oh boy. Parallel lines imply alternate interior angles congruent. I have been preaching this all year. Just because we end a unit doesn't mean everything we learned in that unit disappears. Here it comes again, unit 3, alternate interior angles. Final step, why are the triangles congruent? What method? Woo, ding, there we go. Tyler, what method do I have here?
Side, angle, side.
There you go. So that's why it was 4 steps. Side, angle, side. Good job, guys. All right, good job. What level do I need you to be at? Probably this level right here, number 12. All right, that's probably the level I need you at. Being able to do that all on your own without any markings on the diagram. All right, you got 2 minutes. Clean it up, submit it. Clean it up, submit it. 2 minutes. Whew. All right, I'm ready to roll. Here we go. We're back to business now. I had mentioned to you guys yesterday that we have 5 different methods. 5 different methods of proving triangles congruent. I showed you 2 yesterday. You get 2 more today. That's what will be on the quiz, these 4 methods. The 5th and final one will be revealed next Monday. All right, so these 4 methods are what highlights the quiz on Friday. So I already have side, side, side from yesterday. I have side, angle, side, where the angle's in between the 2 sides. Here's method number 3 to prove 2 triangles congruent, ASA. ASA. I think some of you guys, based on the work we did yesterday, know what ASA stands for. Angle, side, angle. All right, angle, side, angle. And some of you are like, oh, wait a second. That S is in between the 2 A's. You're darn right the side's in between the 2 A's, because you can only use this method if the side is in between the 2 congruent angles, like I have on the diagram for you. All right, it works just like side, angle, side does. The side needs to be in between the 2 angles. And if it's not, if the side is not in between the 2 angles, hey, it's still all good. It's all good in here. Even if the side's not in between, you still have congruent triangles. You'll just need AAS instead. Angle, angle, side. We're okay. We're still okay. So if you have 2 angles and a side, you got congruent triangles. The only work you need to do is to figure out if the side's in between or not. Okay, so 2 angles and a side, you guys are good. So go ahead right now, and we're just going to jump right into a proof. Short notes today, 2 proofs, and then I got a challenge one to do on your own. So let's set this up. QS bisects angle PQR, angle PSQ, congruent to RSQ. All right, let's do this. Let me mark the 2 congruent angles on here. PSQ, boom, and RSQ, doom. There we go. All right, from time to time, and this may help you out, I don't know. Some students in the past have done this, and they said it's very helpful for them. Because you have 4 methods now to keep track of, anytime you write down an angle or a side, watch what I'm going to do here. So in the givens, I have PSQ congruent to RSQ. That's a pair of angles, so I'm going to write a little A next to it just to tell me I have a pair of angles already. You do not need to do this if it's not going to help you. This just helps keep track of what angles and what sides I have. All right, it's on you guys now. This is on you. What else can you tell me is true in the diagram, either from a given or something you can do on your own? Give me something else that's true about this diagram. Let's go. Come on. Sarah?
Because QS, it's like a shared side, so we can use reflexive
Nice.
and say that it's congruent.
Good job. Sarah just got a pair of sides for us. SQ, congruent to itself. Good job, Sarah. I got reflexive. And watch what I'm going to do here. That is a full pair of sides. So right now I'm thinking to myself, I got a pair of angles and I got a pair of sides. I just need one more pair of something. Because remember, to do any of these methods, you need 3 pairs of congruent parts. And I only have 2 right now. Where's the 3rd pair going to come from here? 3rd pair. Come on, dig deep. Ellie, where's the third pair going to come from?
Angle PQS is congruent to SQR because of the definition of the bisector.
Unbelievable. PQS congruent to RQS. Put my angle symbol in there. Yes, that was in the Givens definition of a bisector. Mark it on your diagram. Congruent. Getting a little messy, but congruent. And that gives me a second pair of full angles. So I have enough now. The only thing you guys have to determine now is the side in between the two angles or not? And I'm not talking about the way I wrote it down. I'm talking on the diagram. Look on the diagram. Is the side in between the two angles? If it is, it's angle, side, angle. If it's not, it's angle, angle, side. So what method do you have for me here? Woo! Going back, Sarah.
Angle, side, angle.
The side SQ is in between the two angles, so she is correct. Nice job. Angle, side, angle. It is in between. And there it is, triangle proof. Not too bad, huh, kids? My guess is, even though you guys don't want to admit it, my guess is some of you guys are starting to find these more comfortable, find them a little easier than what we've done in the past, which is a good sign. I always say, at the after unit 4, if you still have no clue about the proofs, time for a change of scenery or a different class. All right, if you're not picking up the proofs by the end of this unit, then it's not going to happen the rest of the year. I'll be honest, doing this long enough. All right, so hopefully you guys are seeing that they're a little bit easier for you, maybe getting them more comfortable. Until I do this to you, throw this proof at you. Let's go, come on. We don't shy away from the challenges. DAC congruent to BEC. DC congruent to BEC. Guys, can you please do me a favor and do not mark your diagram. If you've already started, fine, but don't mark your diagram yet. Big breath. First thing, after you write in your givens and after you write in your givens, check out the triangles you're proving congruent. Triangle ACD and triangle ECB. Whoa. They're kind of right on top. They're overlapping, aren't they? ACD and ECB. We've never had this before. Anytime I ask you guys to do a proof, let me throw one up here that we've done before. The triangles have been separated. Nothing has overlapped before. Any of the triangles I've asked you to prove in class or on homework, they've always been kind of separate, never overlapping. Here's the first overlapping. If they are overlapping, I'm going to ask you guys, I'm not going to suggest, I'm going to ask you guys to do the following. Highlight both triangles in different colors. And you guys doing your notes on the Chromebook, that shouldn't be an issue. You guys can just pick a different color to use for your stylus. You guys that picked up a packet or printed out the notes, if you have highlighters, colored pencils, use them. You only need 2 of them, 2 different colors. That's it. All right. Watch how easy this is going to become when I highlight them. So here's triangle ACD highlighted. And let's highlight triangle ECB. ECB right there. Got them. Okay. Now let's look at the 2 givens. Angle DAC. Angle DAC. Does everyone see how angle DAC is a full angle in my yellow one, ACD? Is congruent to BEC. So everyone mark BEC. And do you see how that's a full angle in my green one? So that given right there is a pair of angles for you. Full pair of angles. Don't give me partial ones, only full ones count. Only full ones count. All right, so that gives me a full pair of angles. What about DC and BC? Let's check it out. DC looks like to be a full side in my yellow triangle. Everyone see the full side I gave you there? Congruent to BC, which is a full side in my green triangle. Oh, so I also gave you a full pair of sides to start out with. And maybe you don't see that. You don't see that they're actually full angles or sides until you highlight them. We need one more pair and we're done. That's it. One more pair. One more pair. I gave you sides and angles. You need to find one more pair, and this is where it gets a little tough. Can anybody find any more angles or sides that might be congruent? And before you tell me, they have to be angles or sides that are actually in both triangles. Okay, full angles in both triangles. Don't give me angles that, like somebody in my 4th period class gave me those vertical angles up there. I don't know if anybody was thinking that. AFB and EFD, they're congruent, but they're not in the triangles I am working with, right? Those aren't the full angles in triangles. So I can write it down, but it's not going to help me, those vertical angles. I need full angles in each triangle. I'm not even going to call on anybody here. I'll let you guys open it up and let me know.
Angles.
Angle, Tyler, what is it?
C.
Everyone, look at angle C on your diagram. Isn't that a full angle in both triangles? Everyone see that? Angle C is a shared angle. And, good coincidence there, Tyler. You're the one that asked this earlier. You can have a reflexive angle. Yes, as long as it's shared in both and it's a full angle in both. So there it is. There's the missing piece. Angle C congruent to itself. Or if you want to name it with 3 letters, you can. Reflexive. And that gives you a pair of angles. Ha! Is everyone all right how I found a reflexive angle there? And I don't know about you guys, but it's pretty easy to see when it's highlighted. When it's not highlighted, I don't know. I'd have trouble. All right, so we do have enough info for ACD.
Nope, we do not. Nope.
What?
We don't.
All right, I am waiting to hear this explanation.
Okay, so we're measuring ED, EC, and EC and AC for the triangles. Okay?
EC
and yeah.
Okay, those. How do those come into play?
Those are the side lengths.
Okay.
And we don't know if AB and ED are congruent because that's no.
You're thinking my markings belong to EC and AC, and they don't. My markings belong to the ones that I was given, DC and BC.
Oh, oops, I didn't realize. I'm very sorry. I did it a different way. I'm sorry.
You done?
Yes.
Remember, I'm the one with the pen, all right?
I'm very sorry.
Raise your game if you want to come at me next time, Christo. Raise your game, all right, if you're going to come at the beast, all right, because you're going to have a tough time taming this beast. ACD congruent to ECB. Well, you thought angle C was tough to find? Wait till you figure out if it's angle side angle or angle side. I want to have an art class discussion and argument maybe about this. Is DC and BC, the one pair of sides you have, are those sides in between or not in between the two angles? Let's have a nice little class argument here. Anybody want to start off with their opinion? Is DC and BC in between or not in between?
They are in between.
I got an R in between there. Anybody want to?
R not in between.
I got an R not. All right, now we're going to take sides. Where does everyone fall in this debate?
I agree with Sarah.
Oh, Sarah's got it.
Crystal.
Oh, there we go.
I agree with Sarah.
I'd say Crystal.
Okay. Looks like we got a half and half here, split. And some of you are like, I don't feel comfortable saying anything because I'm not even too sure. And that's okay. That's okay.
I agree with Sarah.
Okay. Good. You got some allies there, Sarah. And if you guys are at home saying, I'm not even too sure, here's what I'm going to suggest. Watch how easy this question becomes now if the side's in between or not. Draw out one of the triangles. So I'm going to take triangle BEC and draw it out from the diagram. Here's B, here's E, here's C. Everyone with me so far? Mark on your diagram, mark on BEC what you marked on your diagram. I marked angle C as an angle. Everyone, yes? I also marked angle BEC as an angle. With me so far? And what side did I mark on that triangle? Side. Anybody want to let me know what side I marked? Because here's the answer.
BC.
Does our question become very easy now? Is the side in between? It is not. So Team Christo there, you got it.
How do we know that we should mark
Go ahead.
B instead of, like, or BC instead of EC?
BC, because look at the given, Sarah. It was DC congruent to BC. It wasn't DC congruent to EC. Right? Hey, Sarah, you're looking at this marking right here. That marking represents EC in my green triangle. I'm sorry, that marking represents DC in my yellow triangle. You can only mark things, Sarah, that you're given, right? EC never came up at anywhere in this proof. It was DC, or excuse, it was BC. Do you see how, Sarah, I'm only marking things that came up in the proof?
Yeah.
Okay? EC never came up. I know it looks like I marked EC on my diagram, but that 2 hash marks that I circled belongs to DC in my yellow triangle. Everyone are okay? So I'm hoping if you guys draw it out, it'll be a little clearer. Angle, side there. Okay, any questions there? All right, with the time we have left, you guys need to find some white space in your notes because this next proof is not in your notes anywhere. So find a spot to put it. This next proof I'm about to show you is the level at this time in this unit our honors kids need to be at. All right, my honors students need to be at this level to do this type of proof at this point in the unit. There it is. Okay, I will give you a second to copy it down. We're not going to do it together. You guys are going to bring this back tomorrow in addition to the book work, and you're going to tell me, you guys are going to tell me how you did it. Low battery. As you're copying it down, I'll keep talking to you. There's nothing I have not taught you about this proof. Now, could I have shown it to you in Unit 2? Yeah. Could I have shown it to you in Unit 3? Sure. But there are no reasons that you're going to put in this proof that I've never showed you before. All right, so do not make up something brand new. Just keep on trucking here. Look, I'm asking you to prove these 2 outside triangles congruent. And one of the givens says that segment KR is congruent to segment PR. So I already gave you a pair of sides right there. So you need to figure out, how do I get more angles or how do I get more sides? That's what you guys got to figure out. Using the other 2 givens, how do I get other sides or other angles? Last thing I'll say about this proof, 7 steps it should be. 7 steps, including the givens. 7 steps. If you guys want to stop by after school, pop in, ask a question about it, or you want to run your proof by me, let me know. Stop in today. I'll have no issues helping you guys out. But I am looking for a finished product tomorrow afternoon at the beginning of class, in addition to the book work tonight. And keep in mind when you're doing it, this is the level I need you at right now, is figuring out this proof. This is the level I need you at. All right, guys? You guys have a good day. Stop by today after school if you want a little extra help on it. Have a good day, guys.